Hi. So today I'm going to talk about the Goldbach's conjecture, which is still unproven, which states that any even number can be written down as a sum of two prime numbers. Now I like to interpret things physically, so this is my interpretation. So let us imagine that we take an even number, arbitrary even number, say 10, okay? Now I take a string of length 10. 1, 2, 3, 4, 5. I can represent this in a number line from 0 to 10. This is my string, okay? Now I take this marker and I draw and I mark all the prime numbers on my string. So which are 2, 3, 5 and 7. I have my string here, okay? Now if you take any number, suppose C, and write it down as a sum of two numbers, then you realize that A and B have to be on either sides of C by 2. Because if they are on one side, they'll either add up to something less or something more than C, right? So now I have to find two primes which add up to 10. So according to this, it means that they have to be on either side of 5, right? Because k minus x plus k plus x is going to give me 2k, which is 10. Okay? So, in other way, you can say that an implication of Goldbach's conjecture would be that any number has equidistant primes. Yeah. So, this is what I have to prove. Now, in my string, what would this mean? This would mean that if I if I bring both ends of my string together so that this overlaps, then there will at least be one point where two primes coincide. I've marked my primes with the marker, so there will be at least one point where my primes are coinciding, which is really nice. So there's another way in which I try to interpret this. So I'll take my string and I'll just make a circle out of my string, okay? So this is my string and this is 10. And all these are my different points of the string that I have marked, okay? So what the Goldbach's conjecture essentially tells me is that I'll have at least one theta. Like if I start from 10, I'll have at least one theta for which the number that I get is going to be prime on either sides. Like if I have a theta, yeah. So it tells me that I have at least one theta for which I'll get prime numbers on either side of 10. Now, when I was young, in my futile attempts to find a pattern to the prime numbers, I came across this thing called a prime wheel or a prime circle, where they have sectors and they list out all the prime numbers in concentric circles. So I'm going to interpret the Goldbach's conjecture with something related to that. Okay, so here I have the prime wheel that I was talking about. So how I interpret what I just told you in the prime wheel is, so I had this number line, right? So since my number of interest is an even number, I'm going to I basically have to prove that every odd number has equidistant primes. I am not going to prove it, I'm just going to show you that this holds here, okay? So let me just take any odd number in this wheel, okay? So let me start with something like 21. Can you see? So you can see 21 here. So basically, I just have to find two numbers which are equidistant, two red blocks which are equidistant from 21, and that would prove the Goldbach's conjecture for 42, okay? So I can immediately find that I have two red blocks next to 21. Let me take any other odd numbers which lie on these lines. Okay, so let's just do it for something like 495. Okay, so I need to find two red blocks next to 495. So I'll go this way: 1, 2, 3, 4. I get the first at 4. 5, 6, 7, 8. The next at 8. Now I'll go this way: 1, 2, 3, 4. Oh, I got it at 4. So I got two prime numbers. 495. So I got two prime numbers which add up to 495 into 2. So I proved the Goldbach's conjecture for this number, right? So this is how I interpret it. Like you give me any number on this wheel, and I'll try to go on both sides. This is an easy way of finding a number, finding two numbers that add up to. So you give me any even number, I'll half it, I'll go on the wheel, go on either sides and find the nearest prime and tell you that this is the answer. Thank you.